Good afternoon, ladies and gentlemen. My name is M.Mizoguchi from University of Tokyo. My topic today is resilience agronomy starting from Fukushima. 10 years have passed since the nuclear power plant accident. A lot of researchers from various fields have been involved in agricultural issue in Fukushima since this accident. Researchers' efforts have been accumulated as reconstruction knowledge, which is about to be revived as an old but new agricultural science to solve problems in the field. In Japan, dedicated farmers developed during the Edo and Meiji era in 17th century to 20th centuries. Especially Dr. Tokiyoshi Yokoi, a graduate Komaba Agricultural School in the Meiji era, so that the agriculture science of that time who had learned Western science were trying to do things without seeing the actual fields, and ridiculed them at a lecture saying, agricultural science flourishes, but agriculture dies. The Japan Society of Agricultural Sciences started with a veterinary society in 1884, and by 1992, 16 societies had been established and now consists of more than 50 societies reflecting the subdivision of research fields. The Society for Reconstruction and Agricultural Sciences became the 53rd society to join the Japan Society of Agricultural Sciences in 2020, last year. In March 1211, the Tohoku region was devastated by the tsunami caused by the Great East Japan earthquake, and the coastal area of Fukushima Prefecture was contaminated by radioactive materials, especially radiocesium, due to the nuclear power plant accident. While the 1986 Chernobyl accident was brought to an end with a sarcophagus treatment, the first human challenge to revive the region continues in Fukushima and accumulate its experiences as reconstruction knowledge for these 10 years. The reconstruction agency in the Japanese government is trying to create an international education and research center that will be the core of creative reconstruction, including an attempt to disseminate such reconstruction knowledge to the world. By the way, what is agriculture science? Rural areas are important places of food production and living environments. Agriculture science should be a discipline that works with the people who live there. In normal science, we search for a lot of literatures and set a theme, a research theme from the literature. But in Fukushima, there are many issues arising from the nuclear power plant accident. So we have a chance to ask dedicated farmers who have returned in the area where evacuation orders have been lifted without defeated by adversity. Ask the rice about rice and ask the farmer about agriculture. This was also Professor Yokoi said. That means only faculty member and students of university go to the field in Fukushima and talk with the farmers. We will be able to see the real issues and come up with research themes. We call this educational method FPBL, Field and Project-Based Learning, that Dr. Sugino talked before. What is resilience agronomy? I believe this is a new agricultural science. According to Cambridge Dictionary, resilience means the ability to be happy, successful, etc. again after something difficult or bad has happened. Fukushima nuclear power plant accident is the most difficult and worst happening. The Japanese government used reconstruction, the words of reconstruction, but I believe resilience is better than the reconstruction because resilience means should be happy, successful again. This figure shows the mind of resident or farmers in Fukushima. Just after the 2011 nuclear power plant, they feel fears or the mind of giving up and disappointed. But some farmers always have hope and some dream, never give up, and trying to challenge new things. In fact, right now in Fukushima, soil decontamination work is already finished. And now we need to look forward and make a new community together with hope. So I'm now trying to challenges of resilience agricultural science in Fukushima. I'd like to show the two examples. One is composting using IoT sensors to recover the soil fertility that was lost due to soil decontamination work in Fukushima. Second example is animal monitoring using LoRa communication technology to protect crops and fields from monkeys and wild boar. This is a first example, remote monitoring of temperature and moisture during the production process of fully ripened compost. This presentation was presented by my student Kentaro Uchiyama. The background of this research is the high quality compost is needed for the recovery of the soil fertility lost due to soil decontamination work in Fukushima. But there is no standard for measuring the degree of maturity of fully ripe compost. So a method to measure and judge the degree of maturity at each production site is needed. This is the ICT IoT monitoring unit. We use the soil sensors, TELOS 21 and TELOS 12. And we insert these sensors into the compost at the depths 20 centimeters, 40 and 60 centimeters, and collect the data using Z12.6. This is compost temperatures. If we mix compost, mix the materials, the temperature increases and decreases, and repeat it like this. And sometimes the temperature reaches at about 80 degrees Celsius and gradually down like this. This is a compost moisture content. If we pour the water from the top of compost, the temperature increase and the moisture content also increases like this and decreases. So from this experiment, we found the temperature and the moisture content management is very important to make ripened compost. Another example is rural network construction. The reason why we did this research is it's like monkeys. Monkeys appears in front of greenhouse in the village. So we did this kind of research. The experimental site is Iidate village. We set the 12 nodes include gateway and 11 sensors node in mountain forest, like this. These sensors is set on about 1.5 meter above the ground. And this is a sensor node, gateway, and cloud server, and collect the data. According to this trial, we found the strength of LoRa signal is not likely to be affected by the distance for the mountain with a 2-kilometer radius. And humidity versus RSSI signal, it was reported that humidity has no correlation with the RSSI signal in urban area, but on this research showed that there is an effect of humidity of RSSI signal in the case of mountains, like this. Here in the midnight, the humidity becomes about 100%, and the signal decreases like this. And the tree density also affected the RSSI signal. This node 10 is dense, a lot of trees around the node 10, but this is not so.
これ八木君から借りてきたんですけど、これだと今できてます。
blue one is 11, and the red one is 10, node 10, like this. the lower the density of the trees, the more
まあ、要する
stable
にこれ
the
が単独
signal.
で映らないってことだよね。
はい。
This
そうで
is
す
a last
何がある
conclusion. Agriculture science is a comprehensive science
要
and
するにこれが単
technology.
独でカメラが映らない。
However, it is now too diverse and fragmented. The new agriculture science is now trying to
で先生
revive
この配
as
信
a
されてる
resilience
ののこ
agronomy
れをこ
like
っ
a
ちで見た
phoenix
見たい
from
と思ったんで
Fukushima,
すけど、
Japan.
これは
So,
ど
let's
ど
go
こ
to
を
the
見た
real
らこの
field
動画の
and
URL になる
talk
んです
with the
なんか
farmers.
どっかに書いてあったような気がする。
Or see you in
どれかな。
Zoom meeting after video session from real field of Idate Village, Fukushima.
その辺がよくわかんない。
Thank you very much.
どれだろうね。まあ一応動いてるわけね。
はい、今ライブできてます。